Okay, this is a podcast that picks up from the earlier podcast, which is what banged, essentially, when I talked about the Big Bang and, how all that played out. What is it that emerged from the Big Bang, and how, at the end of the day, it's not really an emergence, but rather it is an awakening within a concept space that is connected by the potential possibility of every type of trajectory. Now, I didn't really go into details of what that means. I want you to think of it as, imagine a space where, you know what an orbit is, or a trajectory, and a trajectory is just movement through that space. But I want you to imagine now that that's why I call them orbits, because an orbit is a trajectory, but it's a trajectory that is elliptical or circular, because of it comes back to its starting position in space, sort of, relatively speaking. So, in a sense, it is closed, in a manner of speaking. Now, imagine a space where every potential type of orbital trajectory is possible, but the possibility exists in such a way that all the orbital possibilities are connected together, meaning there is no gap between them. The kind of structure, the simplest structure that emerges from such a possibility space is the set of all natural numbers as represented in a three-dimensional space as my model, basically speaking. Because what I did in the creation of my model is I represented natural numbers as in a three-dimensional form. That's not quite accurate, is it? It's the type of representation I used created a three-dimensional space. And I used a very natural representation. I just represented the numbers as orbits. So imagine every number is an orbit, but it reverberates infinitely often. So every number is an orbit. You can decide to make the orbit the size of the number, or the scale of the orbit can decide to represent the size of the number, but it reverberates infinitely often without damping. And then all the orbits, all the possibilities, which can only be 1, 2, 3, 4, 5, they are reverberating at the same time in that possibility space. So what that gives you is a structure. It is the simplest of such structures, and that is the concept space from which everything emerged. Because everything we see as a physical reality is an imitation of that structure. And within that structure, you can see whenever we're talking about the set of natural numbers, the densest part of the set of natural numbers are the prime numbers. And they are dense in the sense that they form the granule upon which the entire set can be reconstructed, meaning they are like the DNA, or the nucleus of the set of natural numbers. You see, so with the prime numbers you can reconstruct the set of natural numbers, and with the natural numbers you can reconstruct the prime numbers. So, and the set of the prime numbers themselves, the distribution between them, the way they are organized, because they characterize the organization of the natural numbers uniquely, and the distribution itself is such a way that it can mimic any dynamic system, any type of dynamic system you can imagine. It can find instantiation in the distribution of prime numbers. And when you look at the distribution of prime numbers in my model, the locations of all the primes, they are interspersed by uh, different factors of 6. So essentially, they are all connected, and they are connected in the same way. All of them. They have this. This is a property that leads to some type of expansion within, but it's a metric expansion. What I'm trying to say is that the metric expansion that we see in the universe is because that same type of expansion characterizes the distribution of prime numbers, the nature of the natural number system itself. There's so many, in my book, there's several examples I point to buttress this fact that look, the existence itself is a mimicry of this concept space. What we see as space-time, the rules of space-time, the rules of quantum mechanics, the rules of general relativity and special relativity and all knowledges that are true, they are contained, they emanate from this concept space as I've described it. You can derive the nature of quantum mechanics from this concept space. You can derive the nature of general relativity and relativity, the special relativity. You can all bring those rules out. The behavior of angular momentum and all that, it's all there in this concept space, because what we're dealing with is the distribution of prime numbers always. Numbers are how we understand relational order. Maybe they're not numbers in nature, but when you need to define what that relationship is, they are defined as numbers, and numbers are simply scales. So we give them numerical values, how we represent relational order, and relational order is scaling. So we imagine 0, which is a nothing, then we imagine one above, something above 0, which is 1, then we imagine the duality of 1, which is 2, and then we imagine 2 plus 1, which is 3. So by the time we think about all the possibilities of relational order that we can form, we arrive at a set of natural numbers. Of course, it's much deeper, because we can begin to we can say, okay, what if we divide 1 by 2? Then we go into a set of real numbers. And then we can also say, okay, what if we take the square root of -1? Then we derive a set of complex numbers. And then we derive quaternions and all that. So a different type of number system, but the basis upon which they are all built, the densest of them all, is the distribution of prime numbers. And that's why then you can describe the prime numbers as being dense, because they form the nucleus of the entire number system. That's the entire system of relational order. The most concise form of relational order is the distribution of prime numbers. So they become, so if you imagine that the entire possibility of number systems is a universe on its own, right? Now the nucleus of that universe, the heaviest objects of the universe, let's just imagine that the entire possibility of number systems is what appears as the planet Jupiter. Then the central core of Jupiter would be the distribution of prime numbers. So you can see how the earliest concepts become the densest objects. If you materialize such a universe, the heaviest objects in that universe, they are the lightest conceptual facts of that universe. So if you think about if you imagine our own universe and you say, okay, let us use our universe as an analogy. If my theory is correct, then the entire universe as we see it is an orchestration of arithmetic analyticity. So that within that universe, which our universe, our perception is the perception of a concept space. We don't see it that way because we are a concept within that space also. So we tend to see everything as having a hard material existence. But what physics, or especially quantum physics and experiments that are taking place in quantum physics, even the standard model basically describes particulate nature now as fields. And fields are concepts.